Welcome, everybody. Welcome to the combined Denver and Boulder Java User Group meetings. I'm Greg Ostrovich. I help run the Denver Java User Group. First of all, Happy New Year. We're hoping 2021 is so much better than 2020. Remember, we are always looking for speakers at the different Java user groups, both Denver and Boulder. Email Matt, Rabel, or myself, or reach us through the meetup group if you're interested. I do have my usual announcements, and they're corny, and they'll continue to be until we meet in person. The housekeeping announcement is if you need the restroom, hopefully you can find it wherever you're watching this broadcast. Tech Systems is one of our sponsors, and they usually sponsor food, and we appreciate their support. Ever since the COVID lockdown, that's been a little more difficult, so tonight's dinner is sponsored by whatever's in your pantry or whatever's in your fridge. Courtney Elterman, celterman at techsystems.com, is our contact with Tech Systems. And again, we thank you for your support. JFrog is another sponsor as well. And they have a raffle tonight where you can enter to win an Amazon Echo Show 5 or one of 3 JFrog t-shirts that they have that are just for the Java users group, for the DJUG. The winner will be selected within 3 business days, and then the winner will be announced on our meetup page and in social media. Scan the QR code or use the bit.ly link that Ari will drop into the comments or the chat box. Apex Systems is another sponsor. Usually they sponsor our beer. Tonight's is sponsored by, again, whatever's in your beer fridge. Tonight, for me, that's Bud Light. So there you go. Braden Collip, thank you for that sponsorship. Reach out to Braden if you have any staffing needs, just like Tech Systems and some of our other sponsors. Another sponsor is Develop Intelligence. They are a training organization, and they've been sponsoring us for quite a number of years, as has Tech Systems been. And you can reach them at pluralsight.com, or not pluralsight.com. You can reach them at developintelligence.com, but they're giving away a Pluralsight training login for that. And there's a little bit about them on the slide that you can see. They're always looking to hire technical instructors who specialize in several technologies. Those include Java, Golang, JavaScript, React, DevOps, tools like Kubernetes and Docker, and many others. And there's a link to reach out to Bob at Develop Intelligence if you're interested. Amazon, we've had a few different contacts. They have a bunch of different things that they're hiring for, different stacks. Go to their website and check it out if you're interested in working for Amazon. Okta, we always appreciate Matt works for Okta, Matt Rabel. They have a great breadth of technology stacks that they support as training and some other stuff, including some great OAuth technology. So reach out to them. They support the meetup site and this online meeting, and we appreciate that. NextGen is another sponsor. Beth Crowley, and there's her contact information on the screen. They hope to have some openings soon. Things can change at a moment's notice, but reach out to them, beth.crowley@nextgeninc.com if you're interested. Tonight's gift will be an Amazon e-card. Another sponsor is agilelearner.com. That's Venkat Subramanian. He's wonderful. We've had him as a speaker a ton of times. And he's created something really special for Agile. There's a subscription to agilelearner.com that we're giving away as a part of the activities tonight, part of the meeting tonight. But he'll also restart. He was going to do a conference. Due to COVID, they've had to reschedule that. And JetBrains is also a great sponsor. They've sponsored us for 15, almost 20 years. So it's been quite a while. And we really appreciate that. And we always give away a couple of licenses. And Mike Suedo will handle all the door prizes. So also my hearty, huge thank you to the DJUG board that makes this stuff happen. Matt Rabel does the speakers and the location, which right now is virtual. And he handles all the stuff for the virtual meeting. Mike Suedo does the door prizes, and Zeddy Chinfong handles the operational stuff that we need, including getting the word out to our social media, creating quizzes or surveys when we need them, and other stuff for the announcements. Okay, so with that, I'm going to have Matt bring up Chris Woyna from the Boulder Java Users Group. Chris has a few thank yous as well.
Hello, thanks everyone. So pretty much the same folks, tech systems. We've had tremendous luck working with Anastasia Alexenko. If you have any questions about the industry or about your career or just in general, be sure to reach out to Anastasia. We've been sponsored by Rule 4. They were last year's Colorado Technology Association winner. Of course, No Fluff, Just Stuff, Jay Zimmerman. They have world-class conferences and training. And Agile developer, Venkat Subramaniam, great guy. Very knowledgeable, pragmatic person. O'Reilly Books, and JetBrains IntelliJ. If anybody is interested in a license, I probably have at least 2 tonight. First come, first serve. Please don't be a prior winner. And just reach out to me through the Boulder Java Users Group site. Back to you, Greg. Thanks.
Thank you, Chris. Yeah, and just a final reminder, all of these people help make the Java Users Group go. So if you can use those sponsors in terms of if you need training, go to Develop Intelligence. If you need staffing, go to some of our staffing sponsors. They appreciate it, and it helps us give away stuff to you for these meetings. So tonight's presentation is on the best country for observing the Northern Lights. And this talk will be about the technology behind that, using Java and some third-party libraries for data representation, and why Java was the best choice. And I'm going to go ahead and read the brief from it. It talks about no matter what kind of jobs, developers, managers, CEO, etc., that we do, all of us have a hobby, and sometimes even more than one is great. So our speaker tonight is not an exception here. He loves landscape photography and found himself in love with the Northern Lights, astrophotography, and many more subgenres of that. So if you haven't seen The Green Lady Dancing Over the Sky, you're going to like this talk. It'll tell you how to do that. A friend of his asked about traveling north from where they live to see the Northern Lights, and he realized it was a complicated answer, and there are reasons for that. How do you compare, landscape, sceneries, experience, culture, and people of that culture? They're all unique. So it was a problematic answer to such an inquiry. So having a background in data analysis and a bit of data science, he decided to solve this problem as a software engineer. Define a problem, find consumable data resources, and do some code for the sake of the result. In this talk, he'll be covering the following parts: how a funny experiment turned into a case study, and how Java turned into the most powerful tool in the context of data analysis. He'll also talk about, why Java, why not Python? And the idea and the key takeaway of this talk are to showcase how your job skills and your hobby can work side by side to produce beautiful results, and how useful Java could be for parallel data pipelines. So tonight's speaker, Dennis Makogon. Dennis is a software enthusiast focused on developing and designing platform and software as a service application for clouds. He's a principal software developer at Oracle, concentrating on product development along with bringing well-designed and production-ready integration with cloud solutions, contributed to various open source projects, cloud-related technologies, along having fun with Internet of Things devices and photography. Dennis is a regular attendee and speaker at the OpenStack Summits in Atlanta, Austin, Paris, Barcelona, and Boston, and PyCon Hong Kong 2016, 2017, PyCon Italy 2018, PyCon APAC 2018, and PyCon Japan 2018. He's also a co-author of the OpenStack application development and OpenStack Trove Essentials, and you can find him at DENIS_MAKOGON. So without further ado, tonight's speaker, Dennis Makogon. Thank you, Dennis.
Thanks, Rick, for the introduction. So let's get to the presentation. Let me just share my screen. Um, on behalf of Java Platform Group at Oracle, Boulder, and Denver JOG teams, I'd like to welcome you at the first meetup of 2021 series. And of course, I'd like to thank today's sponsors for making this event possible. Let me first introduce myself. My name is Dennis Makogon. I'm a principal member of a technical staff at a member of Java Platform Group who's responsible for Java development at Oracle. As Greg said, I'm a frequent attendee of multiple conferences around the world. But let's just go directly to the topic of this talk. So, as many of you, I'm a software engineer, meaning I write code for a living. Alongside with my work on my spare time, I do a landscape photography as a hobby. People on the internet call me some kind of a pro-level landscaper. Well, maybe because one of my photos, and not only one, are winning photos at the very prestige awards. And the latest one is the best photo of 2019 for a bloody annual pilot whale massacre at the Faroe Islands. Like maybe that's why. So what's this all about? So you're here to listen a quite interesting story of how my both skill sets in software development and the professional landscape photography align together, and how such a collision turned into a great story of the Northern Lights hunt. It all started with a very simple question from a friend of mine: which country is the best to witness the Northern Lights? And I was kind of uncertain to what to tell him. So I told him the next thing: pick the one you like the most. Go to Alaska, go to Svalbard, Iceland, Norway, Russia, Finland, Canada, Sweden, and Greenland, or north of the Scotland or Shetland Islands. If you haven't been to any of these, just decide upon your budget and go whatever is those. Go to whatever place you like the most and fit your budget. From the standpoint of a physics, the fact of the Northern Lights' presence up in the sky is a coincidence of multiple factors. So the Northern Lights phenomenon is a lovely dancing colorful waves in the sky, something that can be described as a set of measures. So I ask myself whether I can answer my friend's question in a matter of a software engineer with a certain background in a data analysis. And from that moment, the answer to the question which country to visit was nothing but the ideal state of a system defined by a set of parameters and expectations. And math equations against that, and the result would be the answer of the exact place to go. So I decided to write a theory, but I haven't been doing this since university. So because we're software engineers, we're not people of science, but some of us, but there's a huge audience who are actual scientists in the engineering world. So as you see, the study is all about matching data by a certain criteria, doing math against that, and a bit of assumptions based on the years of the observations of the Northern Lights. So in 2019, the idea of Northern Lights Awards was born. It's a great attempt to give an answer to a simple to give an answer in the simplest form, consumable by non-tech people, because the whole theory of the Northern Lights is quite complex, and you need to know a lot about our sun, Earth, its magnetic fields, and electromagnetics. So it's pretty complex theory, but I don't want to waste your time on listening to the whole theory. If you'd like to learn a bit about this case study and the theory behind that, you can visit my GitHub repository following this link or using the QR code on a screen. So yeah, but first of all, I'd like to, before we do a deep dive into technical aspects, I'd like to acknowledge two organizations. First is a Dark Sky web weather service that does provide a historical weather forecast, which is very useful if you want to check what was the weather in past, because the whole case study in first place built against the historical data, because we always measure to what happened in the past in order to identify whether we can predict to whatever is going to happen in future. And also, I'd like to acknowledge the Helmholtz Center of Potsdam. It's a very big university. It has multiple research laboratories around the north. They have one in Greenland, one in Iceland, one in Norway, and as far as I can recall, in Finland. And they collect the data, the data related to geoscience, and they provide this data for free for the researchers, for the data scientists, and etc. So the visibility of the northern lights is very dependent on when, meaning the season, where, of course, far north, and what are the weather conditions. So these are like three things we're not in control, but as engineers, we do make decisions which technology we use to accomplish our tasks in more comfortable and the most efficient way. So the term comfortable is kind of tricky here, as it actually declares a set of demands to the technology, and it has to comply on 100% rather than just go above some abstract desired threshold. So let's speak a bit about those requirements. The technology must be comfortable enough to work with sequences. In the case study, each country is represented by a set of GPS locations, in particular 9 or more. Each GPS location is described by 8 daily measures, like each daily measure described by an hourly weather measures. Sorry, and through the autumn, winter, and spring. It's like sorry. Okay, sorry for interrupting. So during the autumn, winter, and spring season, which is like 226 days. So basically, it's at the bare minimum, it's a 3,000 measures per single location. So the amount of data is quite big for a single country, and it goes beyond that when you include all locations that describe a particular country in this case study. So it starts with a sequence of a country-based GPS location that are an entry point to the further sequence. The GPS location sequence expands with the weather forecast bound to the particular date and the particular hourly hours of a nightly hours. So and ability to build reusable data pipelines is very critical here, as the whole problem-solving algorithm in this case study is a set of sequenced perceptrons or processors that process multiple point-connected data sets from the dark sky and from the Helmholtz University into a compressed, joint, country-based statistics. So since the case study is some sort of a yearly challenge, the technology must be capable of running parallel perceptrons or processors in parallel. So the good thing is that the data is quite effectively splittable, because at most of the times, the data points are not dependent on each other, and the pipelines against those data points can be executed in parallel. So technically speaking, each country can have its own pipeline that must be capable of to be paralleled to run perceptrons for each GPS location, for each weather forecast on this location within the nightly hours through the autumn, winter, and spring. So basically, I'm describing the amount of data that is necessary to be processed. So both the Helmholtz Center and the Dark Sky provided the data through the API endpoints, the HTTP REST API in particular. So in the context of parallel pipelines that I described before, it's very important to reduce the amount of blocking HTTP calls, and ideally with some kind of a non-blocking technique, because within the pipeline we need to do a dead data extractions, and to make the whole pipeline very efficient, we need to make sure that the IO framework is capable of doing the batch HTTP calls in very efficient way. And of course, the type system is not very critical, but still quite important, as there are some data types that require additional manipulation. So all I wanted to see is the same API to work with, because I don't want to really pull out my hair out of my head because something is not supported or require me to write a ton of code to get a simple value process so I can work with the data later. And having all these demands, I decided to compare multiple technology, and I started with, of course, Java. So yeah, Java is for data science. Don't you surprise, like Ancha? So there are like multiple why Java, and I'm gonna list out some of them that I found critical for such tasks, like my case study. One of the greatest thing that happened to Java collection framework was an introduction of Streams API. The first iteration of Streams were introduced in the JDK 8 release, and as per the JDK docs, essentially Streams are classes that are built like a functional style classes that basically consisting of two type of operations, the intermediate one and the terminal. So it may sound kind of a complex, but in the practice, it's fairly easy to understand. The GTK docs say that the presence of intermediate and the final terminal operations, which are combined into a form of a pipeline that contain a source followed by intermediate step and a final operation that turns that makes the pipeline execute and provide a persistent type. We're saying that all intermediate operations against streams are lazy ones, meaning that they won't be executed unless the terminal operation is declared. And here are like few examples of the intermediate and terminal operations. So as you know, streams have like functions like filter, map, skip, reduce. They are intermediate, meaning that a return value of that is a stream, but not a persistent type like a list or any other persistent types. And the final operations are, of course, collect, find first, that providing an optional object that may contain the result, and of course for each, which is known as a terminal operations against a stream. In a case study, streams are actually used as the pipelines of an intermediate operations, like providing a mapping of nightly hours with the corresponding magnetic field disturbance value that is higher of the particular threshold, performing per month filtering for more precise statistics for a particular country, retrieving highest magnetic field disturbance value during the night hours, and comparing that to the highest value through the winter season, which is known, which starts at the autumn and ends in somewhere in May, actually. So no doubt streams are really cool, but that's not all. Streams utilizing a common fork joint pool to run the processing units against a number of threads in a pool. So no matter what you do, as long as the data can be effectively distributed with the parallel streams, the workload can be divided within a configurable amount of threads that potentially can give a boost in the performance. Sorry. To understand, to understand how the runtime executes streams in parallel, I highly recommend to look at the source code of the JDK. But to save you some time, here's a brief description of how Java Streams API utilizes the common fork join pool to distribute the tasks against the several threads in a pool. So there are like two possible scenarios here from where the pool comes from. There is a common pool, the one that is provisioned by the runtime, and with a customizable parallelism level defined by number of available CPUs, but lesser by one. So this is like the configuration that you can hook in at the very beginning. So when you launch the runtimes, then specifying a system property for the Java runtime. And of course, there is a custom fork join pool, a developer defined pool with a customizable parallelism factor. So basically, you can define as many threads as you want to be contained in this particular pool, and then execute a parallel stream within that pool. And the Streams API will pick the custom pool instead of the default one. But in common cases, in order to get the best performance out of the box, it's recommended to use the default configuration, which is dependent on the number of CPUs. So whatever, if your machine has, let's say, like 32 cores, 32 CPUs, the base configuration would be 31 thread, and one thread will remain, the one core will remain vacant for whatever other task will appear within the runtime. What's the key difference between these two pools? So the one is defined by the runtime, and you barely can change the configuration of that, except the base configuration of the parallelism. And the custom pool, you have more control about that against that, because you're defining every bits of it, the name, also the parallelism factor. Can you define, and you can define within that more threads than within the common one. So running parallel streams is really fun. However, a stream is executed in parallel, and the runtime partitions the stream into multiple substreams. The aggregate operation iterates over the process with the substream in parallel and then combines the result. But the trick here is that the parallel streams may not serve its purpose in the most efficient way, and there is a reason for that. While aggregate operation enable you to more easily implement a parallelism, it's still the developer's responsibility to determine if an application is suitable for parallel executions. We all know that the runtime is pretty fast, and the only slow thing is our code. So the effectiveness of the parallel execution of an application, and a parallel stream in particular, can be expressed in a very simple way. As long as the computational cost of a single item processing through the whole data set is higher than the overall infrastructure provisioning overhead, and the data set is effectively splittable, then the data set processing should be considered to be executed in parallel, because it does make sense to execute this in parallel. I know this sounds kind of a complex, but let me explain this. So if an operation is so simple and the execution cost is lower than the overhead of a thread provisioning, then the data set must be very big to make the parallel processing worthless. So it works also in the other direction as well. So if a computational cost of a single item processing is high and the data set is effectively splittable, then the size of the data set may not matter in order to make the parallel execution worthless. So as we all know, so in terms of the effectively splittable data sets, as we all know, the most efficiently splittable collection types include array list, concurrent or a simple hash maps. The data structure tend to be effectively splittable if they internally support a random access and efficient search, or ideally both these operations. So on the other side, if it takes longer to partition the data to process it, then the effort of the parallel stream would be wasted, because the time you spend on partitioning data and distributing the chunks of that data among the parallel among the thread and doing the aggregate operation, in the end of that, the cost of all these operations would be higher than the cost of processing the whole data set sequentially. So basically using a single thread to process the whole data set. So, so why I think the streams are very efficient to process to do a parallel processing of the data of the same type or the same nature is that a stream just stores its own metadata, but 0 bits of the data set itself. So the only moment when your app starts gaining memory while processing the streams is when a stream turns into a collection, basically at the terminal operation. And we cannot talk about threads and not mentioning the Project Loom here, because a Project Loom is actually intent to eliminate the frustrating trade-off between efficiently running concurrent application and efficiently writing, maintaining, and observing them. It links to the strength of the platform rather than fight that. It also makes the parallel execution of streams more efficient, but you need to basically understand how you should build your applications. But Project Loom is basically will allow you to write your programs in a familiar style using the familiar APIs in harmony with the platform and its tools, but also the hardware to reach the balance between writing write time and the runtime cost of your application will widely be appealing. It does so. Sorry. It does so without changing the language, with only minor changes to the core libraries and APIs. A simple synchronous web server will be able to handle many requests without requiring more hardware. And the same thing it also applies to the streams. So in terms of the data processing, a new concept of virtual threads that introduced by Project Loom will make us, people who work with the data, rethink stages when we retrieve data, we process data, as the Loom will help to increase the productivity of any IO-bound tasks or operations by executing more operation at the same time, because a virtual thread itself and the blocking of it is cheap. If you're not familiar with the concept of virtual thread, I highly encourage you to go and read the project documentation. But in short, you probably know that in JVM you have a you have threads that basically mapped one-to-one to a operation system threads. But Project Loom changes the internal behavior of a thread without changing the high-level interfaces and the APIs. So with the Project Loom, a thread will no longer map one-to-one to the OS thread, which will make a virtual thread a Java object, which and the amount of threads that you can spawn, the amount of virtual thread you can spawn for doing the IO operations will significantly increase, and the blocking would be cheap because we're no longer involving the underlying operation threads blocking mechanisms. So, however, with Loom, the data extraction should come beforehand any CPU-bound operations, and the number of the actual operation system threads is used by fork join pool is way smaller than a number of virtual threads. So imagine this situation when you need to write a data processing pipeline, and certain steps of the processing require you to do an IO operation. So let's say like in HTTP requests, you can make those requests more efficient if you would run those requests within virtual threads, but not within the OS threads, because you can within the virtual thread you can basically spawn more threads and do more HTTP requests in parallel, which is I found very efficient because I had in this case study I had to do lots of HTTP requests in order to get the data from the Dark Sky API's weather service and the Helmholtz Center University, because they provided data through an FTP server, and so on. So depending on the tasks, a stream declaration. So yeah, of course. So going back to streams. So streams are efficient in terms of parallel processing. The streams are efficient in terms of memory because they do not store the bits of the data set, but rather its own metadata that represents the processing pipeline. And of course, streams have a comfortable API interface. So depending on the task, a stream declaration could potentially have multiple forms. Just recall for each terminal method, the map API and a collect API. So basically they have a different structure, but still it's quite easily to identify whether you're working with a terminal step or the intermediate one. And by the design, stream objects are not reusable. And if you would try to run a stream pipeline against again, you would get an exception that will be thrown by the runtime saying that a stream is closed. So that's why it's so important. So in my case study, the data for each country is nearly the same and the pipeline remains the same. So all I wanted to have an ability to write a single pipeline and then supply the data to that. But as you know, the streams are, in most cases, streams are bound to the particular collection, but still there are some certain ways of defining the reusable pipelines. And there are like a couple of ways of doing so. So there is a function interface that allows you to pass the collection to a particular parallel stream, or through the supplier interface. And the key difference is that within one you can make a stream processing repeatable but not configurable, but through the supplier interface, for instance, you can make the processing parameterized and so on. So if you want, so it's just kind of like a code construction trick, but it really works and it really helps to build a reusable pipelines within the application, and to make yourself assured that you wouldn't face a problem of a closed stream. Oh, the other thing of the case study that I found very comfortable in Java is the HTTP API framework. So it was a new thing incubated in JDK 9 and fully integrated in JDK 11. A new client, a new HTTP client, provides synchronous and asynchronous API mechanisms. It also supports like all popular stuff like HTTP, the common standard 1.1, the HTTP2, both synchronous and asynchronous programming within both synchronous and asynchronous programming models. It also handles requests and response bodies as a reactive streams, and follows the familiar builder pattern. So you can define how you can accept the response data. Would it be so there's like multiple interfaces, so you can basically identify what kind of a data is coming from, and those so all these features of the HTTP API framework are very useful because they help you to structure the data without going to a third-party libraries that basically implement the same API. So if you need a very basic API features doing an HTTP request in both synchronous and asynchronous form. So the built-in JDK 11 HTTP client is perfect, and it can do whatever you want to do. So what you see on the screen is basically a number of HTTP requests that I need to run within the pipeline. So this is like the optimized number of HTTP requests required to obtain the weather forecast for the case study. So these HTTP calls are performed within the data processing pipeline, which technically means that nearly 55K possible blocking operations will appear within the pipeline. And for certain of them, there will be some kind of a pause or waiting, because the services that provided the data for this case study, they also have a rate limit and also have a back off the timeout to make sure that users are not basically DDoSing the service by trying to identify, trying to pull the data from it. And from the resource utilization standpoint, having this amount of requests and even having a certain portion of that being blocked, it's kind of unacceptable to waste the runtime time for just idling, because when you run on your laptop, you're not really paying a lot for that, rather than paying for the electricity. But when you run this kind of a stuff on a cloud, when you're paying for the uptime, it's very important to reduce the amount of time spent on the execution. And here's where the Project Loom once again will do the job well. So in case of the JDK HTTP API, we would no longer, with the Project Loom, we would no longer need to write a sync code because we didn't need to run a synchronous code to make sure that we execute multiple HTTP requests in parallel using the OS threads. We can utilize the default feature of a Project Loom and then run synchronous code of the HTTP requests within a virtual thread that will handle all the IO blocking operations, and will make it way cheaper than the blocking operation that happening within the OS threads. So the virtual thread scheduler will handle all blocking, and that's the way to make all the execution cheaper. So, and you can basically start all those HTTP requests, all those 55,000 requests in parallel, just as they are, and it will work ideally, and it will work even better than if you would do the same operation right now. However, you need to. So what I had to do with this? So I had an HTTP request within the pipeline, but I figure out that in order to make the whole execution more efficient, and then and make and use OS threads and the parallel use parallel streams that will utilize the OS threads to make the parallel stream process only CPU intensive tasks, and then extract whatever the IO operation is before that, in order to make the execution more efficient, and then utilize the resources of my machine, or like a container or a virtual machine, whatever your appliance would be. So yeah, that would be like the most efficient way of doing so. But still, a choice of a backend of a thread is a responsibility of a developer. So would an app run within the virtual threads or OS threads? Your code, it's your code. So you write your own code. Then somebody will chooses whether to run the code in virtual thread or an OS thread. So it means that if you the Project Loom will handle all possible cheap blockings on the IO operations, but it's not really a good idea to put any CPU intensive logic into virtual threads, because they will bring more valuable results in terms of the execution time and resource utilization if they will handle all the IO operations. Because like the virtual threads are still threads, they are like the same construct and just the same runtime that allow you to make more to run more executions of them. More threads mean more requests, more concurrent requests executing in parallel, which is way more efficient than doing the same within the OS threads. So as I said before, like for OS threads, the more efficient way of executing any CPU intensive operations is to define the number of threads in a fork-join pool that is used by streams, and the number of threads in that in the pool should be lower by one. I'm sorry. Should be lower by one to make the course utilization more efficient. But with Project Loom, you no longer need to keep in mind how many cores you have, what the parallelism factor would be, because with the virtual threads, you can run more IO operations, because you no longer rely on OS threads directly. The Project Loom and the scheduler of the virtual threads will handle all the execution and blocking on the IO events for you. So yeah, let's get to the point. So when people start talking about the data analysis, data science, they mostly talk about tools they've got used to work with. But Java wasn't among of them, except those cases when some applications written in Java are involved, like Hadoop, Spark, and etc. However, Java is one of the most powerful tools that I've used for concurrent data processing. So no matter whether the processing be a CPU bound or IO bound operations. So if there's a need to process the data of the same type or a nature, it's better to use parallel streams. And that's what I did, because other technologies are not providing a feature of the parallel data processing out of the box, but Java does. And the streams are like the best way of doing so. Like when it's an HTTP framework, like when it's necessary to retrieve the data through the I/O channels, an HTTP framework does the job at its best by providing necessary features of both synchronous and asynchronous API. And once again, Project Loom will rock your world. Like, moreover, the things will get even better when we apply the Project Loom against the threaded apps. Not just because of a new concept of a virtual thread, but because the way we treat threads. The Project Loom will help to reduce the overhead of the OS threads management for IO-bound operations, and will basically allow developers to execute more parallel operations without keeping in mind the blocking the overhead of the OS threads. And in my case study, I'm specifically talking about the HTTP request, for instance. So yeah, Project Loom will basically change the landscape of the data of the Java applications who've been doing like a concept of the ETL, which is the extract, transform, and load. So you can use Java to do all these steps in more efficient way, even if it's right now is efficient, but with the Project Loom, it will basically change the way it works right now. And going back, and for me as a hobbyist, Java served a great job with very little effort. So it was one of the most complicated it was one of the most complicated tasks, was to write a theory and define the data processing pipeline on a paper, while the coding wasn't that hard. And Java streams played well for dataset processing, asynchronous APIs. It helped to reduce the time of the whole data processing, and consume resources and make the resource consumption more efficient while working with the data coming from the dark sky and Helmholtz University. Yeah, and it's all started with a very simple question. And all you can see here is basically a result of a case study. So yeah, I don't want to just reread whatever you see on the slide here. So we will go back to this one. But in the abstract, it says why Java and not Python. At this point, you may have a question regarding why I haven't picked anything else like Python that is pitched as a best tool for the data science and machine learning. Well, I have an answer to this. So the answer would be a nature of a Python and similar technologies. It's technically slow and single-threaded runtime, and the most of the data science and machine learning code that exists right now is nothing but a C or C++ code. Sorry, with a very thin wrapper. On the very thin Python wrapper code on top of that, and also you add a dependency. You also add the dependent interpreter as a dependency, while you can link your Java code into a native image using standard tools like JLink. So you would no longer need a runtime, but you will have a very custom runtime that will contain all your code and all your dependencies, if that, of course, possible. And also, Java has a lot to offer to data scientists and data analysis, and the ecosystem of Java is still kind of growing, and more tools being developed and introduced to the community. For instance, like Tribio, that will occupy its market share and the specific tools for machine learning and the data science. But there's no point to sit and wait for that moment. As you can see, that even with the JDK only as the only tool you have, it's possible to do so many cool things. Just look at what I did, and this is like how the whole idea of this case study led me to do a development of this case study and building the Northern Lights Awards. So going back to the very beginning to where it's all started, to a simple question that my friend asked me, like, what is the best country to witness the Northern Lights? And the answer is, pick the one you like. But if you want to have higher chances, pick the one from the screen or visit my GitHub. I will soon publish the results for the season 2021, and you will see once the world will get back to normal and we will be able to travel, you can basically figure out. Well, you can use the data to plan your vacation properly to witness the Northern Lights somewhere pretty close to the Arctic Circle. So, and probably we're done. Hope you find this talk interesting, even though it wasn't packed with so many technical stuff. Anyways, thank you for listening, and I'm really glad. So, if you have any questions, just shoot me with them. Going back to you guys.
So thank you, Dennis. We did have a question from the chat that I wanted to ask from Jim Fox. He said, could you use spatial analysis in a GIS as a pre-step to build the input data to seed your data?
Oh, once again?
So could you use spatial analysis as a pre-step to build the input data to seed your data set? And then he has an example here. For example, build a map with layers of weather, bursts, etc., and define an area visually and use as a GIS-based filter to read the sources.
It's actually something possible, and it's something I've been considering that. But having me as the only person who's been developing this, so I'm doing this for fun. So on my spare time. So if you want to help me to build this, I will really appreciate it. But as for now, it's only like the textual data, and I will appreciate if someone will help me to build this in a more in a better visual way.
So yeah, Jim just said he works in GIS, so he has that kind of mindset, and looks like he might be interested in helping you out. So could you share the URL again? Actually, Greg gave it to me, so I can grab that to the project itself.
I can find it pretty fast. Let me just.
This is the GitHub Northern Light Awards, right?
I will just I will share my screen quickly.
Okay.
So it's the GitHub Northern Lights Awards and Dash Awards, or you can use your phone to scan the QR code, which would be more easier and faster, I guess.
All right. Nice. Well, thank you so much. That was the only question we had, so I'll give everyone some time back in their evening, and we'll bring up Greg and Chris here so everyone could say goodbye to our audience, and we'll see you next month.
Yeah, thank you. Hope you find this talk interesting. If you have any questions, just shoot me on the Twitter. I will glad to answer that. And thank you guys for letting me to speak this. I hope you find this talk quite interesting, and I really appreciate if you will share any feedback regarding that.
Yeah, it was wonderful. Thank you very much.
Yeah, thank you, Dennis.
Thank you.
I really enjoyed it, and I shared the link on the meetup as well, so you'll see it there. And I think I tweeted it too. So definitely, if you want to plug in and kind of look at the project, and there's options to do that, and an easy way to do that. Thank you so much.
Yep, sure.
All right,
Thank you, guys.